Hello everyone. Today we're going to take a look at how QVM smart contract execution engine works, and we'll go through the step-by-step tutorial and show you from scratch how to write a smart contract in the Go language, deploy it onto the blockchain, write some data to it, query data out of it, and how to interact with QVM interface in general. So first, let's head to the website. Let's head for the QVM multi-language smart contracts. Okay, let's dive right into it. Here is some general description on how to work with this. So first step is installing qvmctl. As you see, it's a Dockerized image. We can use it through Docker. So the first step is to install Docker for your platform. In this case, we are doing the demonstration from macOS. This machine is running macOS Monterey 12.6. And actually, Docker is compatible with many more recent versions, I think backwards to until Catalina, but you can check the Docker documentation on that. So let's load Docker. Should download fairly quickly. Right, now we double click the downloaded disk image and we just drag and drop Docker into the applications folder on the Mac. It needs to copy the application out of the disk image. Till then, I'm going to close these and head back to the documentation. Okay, let's open up terminal as well. Let's check the progress. Okay, so it's now installed. Let's open it up. It's verifying it as it's fresh download from the internet. It should launch right away. Yes. This application has been signed by its developer, so it should be fine. We don't want the tips. Thank you. Let's wait for the engine to start up. All right. So it's running now. We can close this window and let me resize the browser window with the documentation. So let's first pull the image of qvmctl. We will be interacting with this tool to accomplish all the steps. I mean, to deploy the smart contract and call it and query it, we will also need another container image for the Golang compiler, which is specific to QVM, but that comes at a later step. So first pull qvmctl. It's pulled successfully. Let's check out the version. Yeah, it states version 0.0.2 as expected. Okay, so let's set up our workspace. So we just make a directory called ws, like workspace, and change directory into it. So just copy paste this command, hit enter. Yeah, we already have this from the previous run. So I'm gonna just remove this one and copy paste again. All right. Then we will generate a random private key using OpenSSL, which is available on macOS. Now we have the private key. And now we will need to determine the wallet address, which is done by copying this one, pasting it as well, and you have to watch out to include that dot at the end. Yeah, so let me make the terminal window a little bit bigger. All right, so it says connected to QVM repository with, and here is our wallet address. And of course, it has insufficient balance. We just opened this wallet, so this is expected, as the documentation says. So first we need to gather some Ropsten ETH. We just paste our wallet address from the terminal window and request some Ropsten Ethereum. This says that expect our ETH to your address within half an hour. Usually this is quicker, but we might need to wait a bit. We can go to ropsten.etherscan.io and paste it, so we can track when we receive the funds. Okay, so after refresh, we can see at the internal transactions tab that we received the 10 Ropsten Ether from the faucet. So we can close this window now. Actually, we can close this one as well. Now let's go ahead writing a smart contract. Okay. So the writing a smart contract section has only tutorials for Golang so far. So let's open that in a new tab. Hit writing a smart contract in Golang. We are provided sample code, so we can just copy paste this as it is and create the smart contract by typing it into a main.go file in our workspace. Okay, paste it, write it. All right. Now the next section is to compile this smart contract. So this is the traditional compilation using the Go tools, but we can build it using the QVM compiler, which will produce a significantly smaller binary size and make the deployment cost of deployment much lower as well as a result. So we just paste this one. It's a separate image, as I said. So this is the compiler, not qvmctl, and this only works for Go code. It says illegal character. Let me see. Maybe it's a wrong paste. Seems fine though. Let's retry. It's on the second line. This is interesting. Okay, let's remove the file, go back, and maybe try to copy using this button. Write it again, and run. This is the same compile command we just copied from here. Okay, something seems to be wrong. Let's jump straight to that line, which is line 32. Okay, it pasted new lines as well because the terminal window was smaller. Actually, the browser window. Let me check that. Let's remove the file again. Yeah, here it's correctly on a single line. So let's copy this again, make the terminal window bigger. Now it should be fine. And now rerun the compilation. Yes, it seems to work fine now. We need to wait a bit until it returns. Now it's done. We can close this tab because we opened a separate tab for the Go instructions. Compiling, we have done this too. Now we are deploying. First, let's verify that our contract exists in the current working directory. Yes, it's there. We see it's around 61 kilobytes. We can pass the H flag to make it human readable. Yeah, it's 60K. Pretty nice, pretty small binary size. And now we can call the deploy function. So what this will do is instruct qvmctl to deploy using our private key, which we have funded in the previous step with testnet ether. And the contract is the actual contract binary name, which is contract by default. So we hit enter. Connected with our wallet. It sees that our balance covers the deployment fee. It has already deployed our contract binary to IPFS. It has verified IPFS deployment, calculated the deployment proof, and now the contract is deployed at this address. We will need this address later. And now it's awaiting registration by one of the QVM executors, which also happened just now. So we see that our contract with this address was registered by this executor node, which is what we want. So let's do, since we will need to work with our contract address, let's do export contract equals contract address. Here it's described what actually happened in this step in detail. So now call the contract. So this instruction is pretty generic because it all obviously depends on the contract what you are going to call. So for this contract, actually I'll go through the writing the smart contract about what this contract actually does. So it's a pretty simple one, just for demonstration purposes. So it only accepts register as a function. So this contract registers users and keeps track of them, and also stores how many total users there are. So if there is a user current key in the database, then let's read that. If the length of this user is 0, that means that there is no current user. So let's use the word unknown in that case. Then also get the total user count and parse it as an integer. And write to standard output the previous name equals the previous name, or unknown in case this is the first call. Then write the current user as the first argument. So I mean second argument, because the first argument was the register function. The second argument is the username we are trying to register. and also store this username under a certain slot in the database. So dbw stands for database write. So we are going to persist these values. And also let's increment the total user count with the previously read total user count plus 1, and exit with code 0 because everything was successful. In any other case, we exit with code 1 to indicate a failure in running the smart contract. So we will need to fill these data out for our specific use case, and that goes like, let me go back to a previous command of qvmctl. We will need to make a call now. Let's give it 10 megs of memory should be plenty. Okay, let's give it a timeout of 3000 milliseconds. And we will also need to read the current username from the database for this call to work, and the total users. So as per the smart contract, let's go back just so you can see. Not compiling, writing. Go. So you see we will work with the user current variable in the call, and also we will work with the total users. So we need to pass these database keys to the call because our program expects them to be present. Let's also indicate that we are going to write 3 slots. So -w stands for 3 slot writes, which we can see by here. So we can expect 3 slots to be written. So first we update the current username. We also store the user index, and we also update the total user count. So these are 3 writes. We will also need to specify which private key we are going to work with, and our contract address, which we are going to call. We stored this previously in the export contract equals and the contract address which we were given. And now we put the arguments, which is register, which is the only function our contract currently supports, as seen here. And let's say first user is the name of the first user we are going to register, and we just hit enter. Yes, we have connected to the QVM repository with our wallet, and we have connected to the QVM contract specifically, which we specified with $contract. It was checked that our balance covers the call fee of this much Ethereum, and now we have called the contracts register command successfully, and now we are waiting for the register command execution. Okay, so what we see is the state 2 means success. The standard output has produced prev name colon unknown, which is expected because there was no previously registered user. So it substitutes it with unknown. And here it was written to standard output prev name, like previous name, equals this name. So this is the expected outcome, and we don't see any error on the standard error. So this is fine. So now what we can do is that we can inspect the state we can query the database of our contract. Let's see what it looks like now. Query contract, and we can check user 0 because that was persisted. We must list the keys which we are interested in. We can check user current and total users. We don't need to specify a private key for this one because it's a read operation, and we can see that it correctly returns that there are 1 users in total. The first user at index 0 is the first user, and the current user is also first user. Also, if you happen to have JQ installed, you can install that using brew install JQ. It's already installed on this machine, so no need to run that. But if we can also pipe the result to JQ to see a nicer output. Yeah, so we see total users 1, user 0 first user, user current first user. Let's register the second user though to make sure our contract works as expected. Register second user. So the same thing happens, connecting to repository and the contract itself, checking the balance, making the actual call. And by the way, just to check what's happening under the hood. So this is our contract. This is an actual smart contract on the Ropsten chain. So we can look for this and we can see live what's happening there. Ropsten is a bit slow these days. Yes, so we can see that here is our pending call actually right now. So if we hit this one, we can see that it's still pending. It should be actually completed already. Yeah, now the user interface of the Etherscan updated a bit late. But now we see as the output that compared to our previous run, which was this right here, which said that the previous name was unknown, now we see that the previous name was first user, which is printed to standard output. And now we can run the same query command, but now we expect, let me clear the terminal. And now we can expect to have 2 users in total, and we can also see user 1, which just got registered by this very call. Yes, so as we see, the total user count is now 2. User 0 was first user, user 1 is second user, and user current is also second user, so the username which was registered latest. Actually, this command, I'll type it out right here. This will work for anyone, so you don't even need to go through these steps because it's public data, it's on the blockchain. So if you start right away with this very command I'm typing right now, you can check that you can freely read the state of any contract as seen. So you just need to docker run with qvmctl query, then the address of the contract you want to query, and then just list the database keys you are interested in. And if you have JQ installed, then just pipe the output into that to get a nicely formatted result. So that was it. This was the tutorial from scratch on macOS. Make sure you check out our other tutorials for other operating systems like Windows and Linux as well. Thank you very much for watching.